Every time a new AI model is released, headlines explode. Bigger models, smarter models, faster models. It feels like intelligence itself is advancing at lightning speed. But behind all the noise, behind every breakthrough demo and viral AI moment, there is a quieter truth that rarely gets attention. Intelligence does not run on ideas alone. It runs on machines. And right now, the most important battle in AI is not about models. It's about the chips that power them. This is the story of why AI chips matter more than AI models. For most people, artificial intelligence feels like pure software magic. You type a few words into a box, press enter, and within seconds, a thoughtful answer appears. From the outside, it looks as if intelligence simply lives inside the model itself, as lines of code, clever math, and massive data sets. But this view hides the physical reality beneath the screen. AI does not float in the cloud as abstract logic. Every calculation, every prediction, and every generated sentence must be executed somewhere in the real world, on physical machines made of silicon and metal, drawing electricity and producing heat. Without the right hardware foundation, even the most advanced model is powerless. It is not intelligence that makes AI possible. It is infrastructure. Intelligence without physical computation is nothing more than a beautiful theory. As AI research advanced, a clear pattern emerged. When models became larger, they became better, feeding them more data, giving them more parameters, and allowing them more internal connections consistently produced smarter, more flexible systems. This success created an industry-wide race towards scale. Companies began building models with billions and then trillions of parameters, believing size itself was the path to progress. But this expansion came with hidden consequences. Bigger models require exponentially more computation, memory, bandwidth, and coordination. The software accelerated rapidly, but the hardware that had to support it did not keep pace. What once felt like a smooth climb is now running into a wall of physical constraints. AI models do not stall because researchers lack ideas. They stall because information cannot move fast enough through the hardware that runs them. Data has to travel across chips, between memory banks, through networks of machines, and every step introduces delay, energy loss, and heat. Training time, electricity bills, overheating systems, and scaling failures all trace back to a single truth. Hardware is the real bottleneck. You cannot out-optimize physics. A smarter algorithm cannot overcome a foundation that is too slow or too fragile. Just as a race car cannot win on a broken road, the most powerful AI model cannot succeed on weak silicon. Traditional computer chips were designed for everyday tasks, browsing the web, editing documents, rendering graphics. AI workloads are fundamentally different. They demand massive parallel processing, relentless data movement, and tight coordination across thousands of operations at once. Specialized AI chips are built for this reality. They shorten the distance data must travel, reduce wasted energy, and allow enormous calculations to happen efficiently and reliably. Instead of forcing AI onto hardware never meant for it, these chips reshape the foundation itself. This is not a simple performance upgrade. It is a structural transformation in how intelligence is physically created. AI chips don't just decide how fast models run. They decide who can afford to build them at all. Efficient hardware lowers costs. Lower costs expand access, and access fuels innovation. When training a model drops from months to weeks, and expenses fall from millions to thousands, the entire playing field changes. Universities, startups, and developing nations suddenly gain the power to compete. Hardware is not a technical detail. It is the gatekeeper of the future. AI models evolve at breathtaking speed. What feels revolutionary today becomes outdated tomorrow, but hardware does not change so quickly. Chips define long cycles of capability, shaping what is even possible for years at a time. That is why the most critical battles in artificial intelligence are no longer being fought in code. They are being fought in fabrication plants, engineering labs, and supply chains. The future of AI is not written in prompts. It is etched in silicon. AI models capture our imagination, but AI chips determine reality. Intelligence doesn't scale on ideas alone. It scales on atoms, electrons, and architecture. The future of AI won't be decided by who writes the smartest model. It will be decided by who builds the machines capable of thinking at scale. And that is why AI chips matter more than AI models.